Hello, this is for class for Wednesday, February 24th, and also my Thursday night class, the 25th. Tonight we're going to look at section 1.6, which is on imaginary numbers. So last week we started talking about, Monday and Tuesday we started talking about radicals. So you're not allowed to have the square root of a negative number. In class the other night, we said when you had the square root of a negative number or a fourth root or a sixth root, an even number here, this number inside cannot be negative because there's no number times itself that equals a negative number. So in Hawks, we chose the little button that said the number was not real. Well, if it's not real, it's imaginary, right? So we can turn negative 25 into basically, that would be the square root of 25 times negative 1, right? Well, square root of 25 is a perfect square. And the square root of 25 is 5. And so we call the square root of negative 1 I. So two rules or two properties you need to write down is I is equal to the square root of negative 1. And if you take a number in a radical such as 2 and you square it, you would get the square root of 2 times the square root of 2, which is the square root of 4, and the square root of 4 is 2. So what happens is when you take a radical and you have an exponent of 2, those two things will cancel each other out, and you're left with what's under the radical. So if you square negative 1, so if you square I, not just negative 1, but square root of negative 1. If you square the square root of negative 1, you're going to get negative 1. So these are the two rules you need to write down and remember, that I is equal to the square root of negative 1 and that I squared is equal to negative 1. So that's what we're going to look at tonight. So here is our tips to remember. The imaginary unit I is defined as the square root of negative 1. I has the property that its square is negative 1. That's what this says. The third one is what I showed you, with the square root of 25 is equal to I times the square root of that number as a positive number, like I square root of positive 25, which was 5I. What is a complex number? A complex number is any two real numbers, A and B. The sum A plus BI is, so A is going to be the real part, and B, that's going to be the imaginary part, okay? And then when would you have a pure imaginary number? You have a pure imaginary number if A, that A part, either of those, is 0. That would be called a pure imaginary number. So let's look at square root of negative 18, x to the 9th. So we're going to rewrite negative 18 as the square root of negative 1 times the square root of 18. Oh man, whoops, previous, no. All right, let me try this again. Oh, there it is. The square root of negative 1 times the square root of positive 18 times the square root of x to the 9th. So the square root of negative 1 is I. We're going to think of 18 as square root of 9 times the square root of 2. Square root of 9 is 3. We can't do anything to the radical, the square root of 2. And then this, you know, how we did the other day, we would write down our 9x's, and then we get to circle 1, 2, 3, 4, 5, 6, 7, 8, 9. For every 2 we circle, we get to bring out 1. So 1 outside the box represents 2 inside the box. So we have 1, 2, 3, 4 pairs of x's. And then we have 1x still in the radical. So we're going to put all this together, right? So we're going to multiply everything outside the radical, I times 3 times x squared. So we have 3x squared I. And then what goes under the radical is square root of 2 times x, which is 2x. And that's how we would write our final answer. All right, let's do the next one. So before we're allowed to multiply these, we have to get rid of the negatives under the radical. So we're going to think of this as the square root of -1 times the square root of 50. And we're going to think of this as the square root of -1 times the square root of 2. So then the square root of -1 is I. We're going to say the square root of 50 is going to be 25 times 2. Square root of 25 is 5, and we can't do anything with the square root of 2. Square root of -1 is I, and this, we can't do anything with that, so we're left with that. So now we're going to multiply all this together. So 5 times I, well, I squared is, of course, -1, and then we have square root of 2 squared, right? -2, or square root of 2 times square root of 2. So the square root of 2 squared, these cancel each other. So that's just 2 times the square, or I get my words mixed up. I squared is equal to -1. Bring down our 5, and then the last thing we'll do is multiply these together. 5 times 2 is 10. 10 times -1 is -10. And that is our final answer, -10. All right, now we have the product of two binomials. So we're going to FOIL this. We're going to multiply the first two terms. So 6 times 6 is 36. The outside term, 6 times I, is +6i. The inside terms, -I times 6 is -6i. And then finally, -I times I is -I squared. So let's see what we have. We have these two like terms. 6i minus 6i is 0. So we have 36 minus, now what is I squared? I squared is equal to -1. So now we have 36 minus a -1. Every time we have minus a negative, we do bam, bam. So our final answer is 36 plus 1, which is 37. That is our final answer. And we got that by FOILing. So here we're gonna take this whole expression and we're gonna square it. So we're gonna do 4 plus the square root of -2 times 4 plus the square root of -2. So we're going to rewrite the square root of -2. So we're going to rewrite the square root of -2 as 2i. Nope, that's not right. It would be I square roots of 2, because this is going to be the same thing as the square root of 2 times the square root of -1. The square root of -1 is I. So both of these are going to be written as this, okay? So we have 4 plus I square roots of 2 times 4 plus I square roots of 2. So now we're going to FOIL it. So 4 times 4 is 16. 4 times I square roots of 2 is 4 I square roots of 2, and then we have those two inside terms, plus 4i square roots of 2, and then finally those last two terms, we have plus I squared square root of 4, right? So let's see what we have here. We have 16. And then these are like terms. So we have 4i square roots of 2 plus 4i square roots of 2 is 8i square roots of 2. And then we have plus I squared times, so what is that? We can simplify this. I squared is -1 and the square root of 4 is 2. So this last term is basically -2. Uh-oh. Where's my pen? Where'd my pen go? Let's see. Square roots of 2 minus 2. All right, so now we have two like terms. We have 16 minus 2 is 14 plus 8i square roots of 2. And that is our final answer. Okay? All righty. And we got that by foiling. All right, let's move on. So now this is not foiling because there's a plus symbol in the middle here, right? So that just means that all we're doing is combining like terms. That's what we're doing. So there's no term like 11i squared. So we're going to bring down 11i squared. We have these two like terms. So we're going to combine negative 10i plus 4i, which is negative 6i. And then 7 is a term by itself. So we have plus 7. Now, the only thing we can do at this point is simplify I squared. So I squared is equal to negative 1 plus 7. So 11 times negative 1 is negative 11 minus 6i plus 7. So now we have two more like terms. So negative 11 plus 7 is negative 4 minus 6i, and that would be our final answer. All right, once again, we're going to just combine like terms. This is a plus symbol, so we just combine like terms the way we see them. So we're going to start with our i's. Well, let's start with our constants. 15 plus 8. 15 plus 8 is 23. And then positive 14i minus 3i is positive 11i. We don't have any I squared. So there's nothing else we can do with this. This is our final answer. All right, so I went to your MyOpenMath, and these are a couple of the homework problems I found. Now, if there's a plus sign here, you just combine like terms. That's all you're doing. So let's start with our constants. 14 plus 3, so 14 plus 3 is 17. And then we're going to combine negative 16i with positive 21i, and we're going to get positive 5i. And that's our final answer. Now with subtraction, however, if there's a negative in front of a set of parentheses, you have to distribute that negative to everything in the parentheses. So we're going to rewrite this. 14 minus 16i minus 3 minus 21i. Now we're going to combine like terms. So 14 minus 3 is 11. Negative 16i combined with negative 21i would be minus 37i. Negative 16 combined with negative 21 is negative 37i. And that is our difference. Okay, 11 minus 37i. All right, on MyOpenMath, I also saw this problem, both of these problems here. So we're going to use the distributive property. So we're going to multiply negative 3i times negative 7, and we get positive 21i. And then we get negative 3i times positive 2i. Well, negative 3 times positive 2 is negative 6, and I times I is I squared. So now the only thing we can simplify is I squared is negative 1. So we're going to multiply negative 6 times negative 1. So negative 6 times negative 1 is 6. Positive 6 combined with positive 21i. They want it written in that form, a plus bi. So that's what we get. All right, on this problem here, we're going to FOIL it. So we're going to multiply negative 4 times 3 and get negative 12. We're going to do the outside terms. Negative 4 times 3i is negative 12i. Our two inside terms, negative 4i times 3 is negative 12i. And then finally, negative 4i times 3i is negative 12i squared. All right, so now we're going to combine like terms. And then since we have that I squared, that is equal to -1. So we're going to do -12 minus 24i, and then -12 times -1 is +12 plus 12, right? So now we have, we're going to combine like terms. -12 plus 24 is +12 minus 24i, and that is our final answer. All right. Negative, I wrote that the answer was, -24i. Let's see, what did I do wrong? I have -12 and then -12i, and -12 times I squared. That'd be, yep, I feel like that's the right answer. I don't think I missed anything on that one. All right, so on that last one, let's talk about it in class. If you see that I made a mistake, will you guys let me know? -12 and then -12i minus 12i, and then -12i squared. Okay, I think that's right. I feel pretty good about it. If that's not right, you guys let me know. All right, well, that's all I have for my notes. So I hope that helped you guys. So by the end of this week, you should have already completed sections 4R2, 4R3, 5R1, and 5R2. And then by Monday, you guys should have these 3 sections done in Hawkes Learning: 1R4, 1.4a, and 1.6. All right, you guys. Well, you guys have a good day, and I will see you for class tonight. And let me know what questions you guys have. All right, thank you.